Is it just me? Alright, saw it flutter there for a second. Ah, there we go. Thank you, Twitch. Okay, looks like we're live. We'll see if that holds. Sorry for the small delay. For whatever reason, my stream wasn't even picked up. Looks good now. Okay, so this week we're going to be doing the interpreter pattern. And I think this one's as good a definition as any. In computer programming, the interpreter pattern is a design pattern that specifies how to evaluate sentences in a language. That's not bad. So, I guess one of the things that is important to note, at least when I think about it, is this pattern changes a lot depending on what you're trying to interpret. So it can be as simple or as complicated as the language, right? So you'll see some examples out there that are, like, once, as always, too simple to be used. Really, they aren't effective. It's like three classes that you don't know what does this accomplish. And you'll have other ones that are just way too complicated, right? Like they're doing like tokenization, they're doing natural language processing, they're trying to do like this Wolfgram alpha level of computation analysis, and those are too far in the other direction. So we've actually got a great opportunity with our game to jump in and hopefully, as always, get a good hands-on version of the pattern that is also usable in other applications. So, there's a context, and there's always a context or an application domain. There's an abstract expression, and then typically there's what we call a terminal and a non-terminal expression. So, and that's actually really easy to understand. Terminal meaning, definite or ending, right? Non-terminal means like unending. So a terminal expression is going to be one that we know the beginning and end of the expression, and we can count on that, right? There's some structure there. A non-terminal expression is going to be something that's just going to be a stream, and we're interpreting as we go. So it's really going to be like your natural language processing. Let's go to a different. There we go. Okay, and not so layman speak. It says a terminal expression implements an interpret operation associated with terminal symbols in a grammar. An instance is required for every terminal sentence, or for every terminal symbol in the sentence. And the non-terminal is when you need an abstract expression, and then for each symbols in R1 through Rn. So, n being this indefinite number of things. And they don't use it for obvious reasons, because you couldn't code an example that was very helpful from that. So, jumping into our game, let's take a look at where we are and the problem we want to solve. And hopefully this will give us a better idea of what the interpreter pattern is going to gain us and why it's such a great fit. Last week we did a bunch of stuff with the adapter pattern and saw how that really changed our application, cleaned it up, got things where they needed to be. I've done a few more check-ins behind the scenes to further clean things up, and we still have a client, we still have a server. If we play the game, we see that our server establishes itself as a listener on port 4000. Then when we start our client, it attaches itself to the server, and it's given its own socket, right? So the server takes that connection and says, okay, I hear you, I'm going to put you over here on this port, and we can have a two-way conversation off to the side. So all the work we did with the adapter was to really define the relationship from this guy to this guy. So that adapter is linking us from client to server. And if I type in something like a bunch of gibberish, it receives on the server and it sends back, hey, there's no player by that name, so I can't log you in. Type in Gary and remove my little breakpoint there. And we get welcome back, and it loads the room that I'm in, so it finds me in the world, and it shows me everything that's around. And I can perform commands. I can get test hammer. I get a little response there. I can look around. I see that Gary looks around. There's no longer a test hammer on the ground. I can inspect Carl, I think. Yeah. So Carl is a husk which moves with some effort. While it appears easy to defeat, its blood-soaked hands and mouth give you pause. Health 100. So this is something that I would want to fight. Around again. Fight Carl. So right now I'm getting two messages back. One is for the room, right? For everybody else who's in there, they want to be able to see Gary attacks for 8 damage. And then I put in a little, like, just say, need context here. Because this is what would you get if you were the target. And there should be another message, a third message that says, you attack Carl for 8 damage. So there's 3 different messages need to go out. One to the target, one to the room, and then one to you. Jim Dude asked, what time do you plan on streaming until? Excellent question. I'll be going until about 7:30. The idea is to make these a little bit shorter, about 45 minutes, so that people who are watching the videos tomorrow or coming back and going through all of them, it's a little more digestible. So, yeah, about 7:30. Okay. So, when I'm looking around and I'm passing in these commands, and let's see, I'll fight Carl again. And get the test charm. And the charm should boost our attack. Oops. Fight Carl. So it gives us a little boost to our attack, because we're running out of stamina here. So we've got fight Carl, fight Carl, fight Carl, fight Carl. Look, Carl. Oops. Inspect Carl. So can we kill Carl with this? Maybe. Let's try. Ah, look at that. So we killed Carl. This is great. Our game is responding. The messages are a little bit disjointed. But things are working, right? And so now that our engine's kind of coming to life and we can do things reliably, now it's really time to go through and clean things up. And we're actually running out of patterns to implement. Pub sub's going to be one. We've got a few others. But looking good. So when I type in commands, they get packaged up by the client and they get sent to the server, and then they're processed by this console process strategy. And here is where our interpreter pattern is going to save us boatloads of trouble. A lot of what's happening in here is to interpret the command. We're trying to match up what action the first word is denoting. We're trying to figure out what the player name is. We're trying to figure out what the target name is. Things don't really belong here. And even though this class, sorry for the fast scrolling, is only a little more than 100 lines, there's a whole slew of things we actually want to add to this later on for the rest of our game. And even if we didn't, we're still overloading the responsibility of this guy. So we want to get these things to places where they should be, so that everything's modular and everything can be extended in the future without having to re-architect or refactor. So, right here, when we say get game response, we are taking in the input from the user, we're splitting it, and then we're saying, hey, the game action is always going to be the first argument, right? The first word is always going to be our game action. And if we can't find it in our list, then we say, hey, there is, and it's none. And then same thing here. If we get more than 2 words back, we're saying this isn't anything that we know how to handle. Game action is none. If the arguments equal exactly 2, then we know that the target must be the second argument. So again, we have this terminal language. I don't know if that's the right way to say it, but anyway, we've got this fixed grammar, right? It's always the statements that's coming in are always going to be of a certain size. If it's 1 argument, then it might be a login, or it might be a command. If it's 2, then the second one has to be a target. And if it's 3, then we know it's gibberish. So now we've got this grammar, and we've reined it in. So it's all we need to account for right now. We want to be able to interpret that in a way that doesn't involve us doing all this hokey stuff. So first, we wanted to find a context. So previously we said that, hey, the context is whatever the domain that we want that we're in. And right now we're in the domain of the game request, right? We're going from the client to the server, and we're passing this request in. And then when it gets to the server, that request needs to be interpreted into a game request. So that game request ends up being our context. So we got a chance to refactor this guy a little bit. So it's serializable. So we still want it to be the game action. And you remember from last week, we decided that this guy was a bit heavy, and what we really wanted to pass around was an action context. So we took player and target out of this, and we threw it in those. So I think we're free. Just do string is player name. Target name. And this is going to be our expression. This is all we hope to interpret out of a command. We hope to get the player name, the target name, and the action. So let's look at real quick. Once we get into the execute, we're building our action context off of our request. So that's really the last place our request is used. So no real danger in making this refactor. So let's go back over to this guy. And we already said we want it to be the expression, so we can see here that we need to have an abstract expression. This is going to be our abstraction, the same thing we do with all of our design patterns. The first thing to do is to abstract out the functionality you're trying to pattern. And then we're also going to have a terminal expression. So we're going to cheat here a little bit. And instead of being really explicit and saying terminal expression, we're just going to say that our game request is our terminal expression. And we're just going to inherit from an abstract expression. Let's come back over to our game. Let's go into common, domain, and now I've got to pick a domain for this guy to live in. So we're doing this off of the console process strategy, which is an easy TCP. So we got a console request in there. And let's look at adding a folder. Called interpreter. It's because it's really the only place in the game where we want, or right now we can envision needing to interpret something. By the time once it gets past this client server, which is the easy TCP framework. It's not. I mean, it's kind of a poor man's TCP client and server, but this is where we're doing our interpreting. And then once we get past that, nothing's really going to care. And we see that inside of the hive mind, where we can say, look, we only need the game request to power our action context. And then that goes falling down the well and comes back to us later. So this is good, though, because it means here there's going to be things we want to do with the game request in the future. When it comes in, more checks, deeper interpreting, just a lot of stuff that's all going to happen at this gate. So we're back in here. We have interpreter. And let's go ahead and say add a new item. And we're going to call it like abstract expression. No reason not to go by the canon. And all they really want us to do is going to have an abstract void called interpret. Now, for our interpret, now context can be anything, right? Context can be a string, it can be whatever you want, and you'll see that if you look around for interpreter patterns, people are just passing in an object. And so that's what we're going to do. We're just going to pass in an object, and we're going to leave it to our implementing class to know what that object is. And when we get into like the Internet of Things, I think this is a really great pattern to start talking about and thinking about. You've got the Raspberry Pi, you've got all these devices, and then you've got all these inputs. So we say that the interpreter is to define this grammar and this language, but it's really more broad than that. It's really this idea of an input. So if you've got a Raspberry Pi board and you've got a little button, and you want to write an interpreter for that button, then here you are. You're at the pattern already. But that might not be the only place your code's going to run. So when you're on the Raspberry Pi and you say, okay, when someone presses the button 3 times, then I want it to do this action. But then when somebody is on their computer, when they hit shift 3 times, then I want to do this action. So you're going to have a Raspberry Pi interpreter, and then you're going to have a keyboard interpreter. And there's no reason to ship the keyboard interpreter to the Raspberry Pi, right? Keep your code lean. Of course, unless of course you want to, add support for it. So we're very close to everyone needing to be able to do these things. It's not just that, okay, well, I've got a console, I've got the web, I've got a web service, right? Those kind of 3 classic places where requests come from. Now it's really opening up. And while we're capturing things in the command line, it could very easily be, look, on my client, when someone presses a button once, I then want to capture the time between presses and the presses for all subsequent presses for 3 seconds. And then when that comes in, you can start determining, well, okay, well, I've got initial press, long pause, press, or long press, right? So you've got all these things you might want to interpret. Okay, enough about that. Let's get back to the fun stuff. Okay, so if we come down here to the real world code, we can see inside of their abstract expression, this is the benefit of the abstract class, that they've done some things with abstract properties. I'm sorry, abstract functions. And we might do something similar to ours. Let's take a quick look. So if I take this abstract expression and I come back to my game request and I say, you are now going to inherit from the abstract expression. And then I also want to make the abstract expression serializable. Come back over to our game request. Let's go and implement our missing numbers. Okay. So, what do I also want my abstract expression to do? Well, I can tell you firstly, I can pull this back out, and I can put this inside of my abstract expression. So now anything that inherits from abstract expression is going to get these three properties by default. And I would like, just brainstorming here, I would like public abstract void to okay, we'll say this. Interpret player? Does that work? Maybe just get player. We'll see. And then, so I'm already making this kind of fancy pants. I'm going to do this. I'm going to do a private, protected, object, context. Let's not make this guy abstract, because I think we know what we want to do. That's kind of the benefit of having these terminal interpreters. Let's come back to the game request. You are no longer needed. But I also want to public abstract void get game action. Public abstract void get target name. So we can get player name. Alright, so we can kind of see where a lot of what's inside of our console process strategy. Let's put that over there. Let's get rid of render strategy and all strategy. Blur to blurred. We've opened up so many things. Alright, that's a little more manageable. So instead of our console process strategy, the first point of reception for the server, we've got all these things. Get game action, get target, get player by room. And they're all private. So let's go ahead and pull all those out of here. Just for the time being, we're going to throw those right there. And then we're going to take all of our implementing missing numbers, those three. Let's do a little bit of cleanup real fast. Okay. So this is our abstract expression that's kind of coming to life. And we're already seeing where it's going to be replacing quite a bit of what's happening here. And we also want this dictionary. That's going to come in handy. All right, let's go and import some stuff. Some types. Okay. So then, for abstract expression, we want to set this context is equal to the context we're getting in. I don't know if I need to make that public. We'll see. And then we're going to say get game action, get player name, get target name. And so this is more or less the structure we want here. It's nice and clean. We know the three things we're going to need. We know the three methods we want every interpreter to have to call them, and we know the order we want to call them in. This is good because this could also go into, you know, if Unity was a client and you're getting back some data from Unity, you need a Unity interpreter, and this is all you would need to implement that. So this is also this idea that you can go ahead and write a lot of your code and feel real confident and safe that it's going to be extendable in the future. And when you extend it, you only need to be concerned with these endpoints, these API points. So come back over to the game request. Let's see. So we have our context here. And we've got game action, which is pretty good. Then we can say that var command is equal to string context. And then we could just say game action is equal to get game action command. So we have successfully ported over that piece of it and in line with our abstract expression. So we want to do that same thing for these next two. Now I will say the only other thing that we want to do, now that I'm thinking about it, let's give this a go and see what happens. I want to do a public void. I'm going to use flags here. Let's see if it's not too busy. And then I want to be able to call something in my interpreter that's going to give me just a little bit of insight before I do anything else. I'm just going to say evaluate context. Then abstract. Come back over in our game request. I kind of want to do this first thing, right? I kind of want to do public, override, evaluate context. And this is where I kind of want to do my, let's go back over here and I'll show you. This stuff. Yeah, a little bit of this, right? So I'm going to say var args is equal to, actually a little bit better than that. We can do this. We can say private string array args when we evaluate the context, we can say args is equal to string. So we're going to cast our context to a string. So far, so good. I'm just going to take this little guy right there. We're going to split it. So this is us evaluating the context. We want to be able to do this for any expression. And so we're using a private field that abstract expression doesn't know about, but it's something that we need to use internally. And we're taking advantage of this little wire up here, this evaluate context, as a way to sneak in our own little proprietary code. So, what else do we have in there? This guy. We also know, we know this just at the initial evaluation, we know that if there's more than 2 arguments, that the game action is equal to none. None. So we know that. So this is also evaluating the context. So now we've got a place to do some preliminary evaluations before anything else gets started. And inside of our abstract expression, we can say evaluate context, and then after we've done that, if game action is equal to game action.none, we can just return. Because other places in the game are going to be able to take care of that. There's no need to try to get the game action or to get the player name or target name. We know it's gibberish, and so we just want to go ahead and just get out of here, don't waste the cycles, move on with our lives. So we're still going to keep this guy clean. We're going to use the evaluate context as well to do has target and has player. So let's come back over here. We're going to put that right down there. And here we're just saying if the length is equal to 2, then we have a target. So this is all we're doing here. We're doing some preliminary evaluations to see if it's even worth continuing. We're setting some flags for ourselves. We're setting the game action. And also we're baking these things into a place that can be refactored in the future. So, come back over to this guy. And then right here, if we say, if it does not, if not has target, it's got some broken, but we'll go ahead and return. So we know there's no need to evaluate the target name because we know that there is no target. So far, so good on the interpreter. And so we're just crushing through this guy. Right? We've gotten rid of this. We've gotten rid of that. We've gotten rid of all these, haven't we? Pretty sure. Yeah, we're doing really good. Okay, so what else? Do. So let's take a step back and kind of look at where we're getting this player name from. Getting from the console request. So at this point, we're almost guaranteed to always have a player name. Or so we're led to believe. So let's modify things just a little bit. Just a little bit. That is something that's unique to the console process. Right? This get game response and this assumption that inside of our console request we're going to have these things, since it's a console request. So, inside of this guy, let's go ahead and give her, I'm calling it a her, game request, and we'll take in a object context, but then also a string player name. Then we're going to call our base constructor, and we're going to pass in a context. Is that going to work? Or do we even care? I don't think we even care at this point, because we're going to be calling interpret later on. Let's get rid of that. So if we're calling the game request constructor, then we know that the player name is going to be equal to player name. And, oh, whoops. Sorry, I put this in the wrong spot. Let's go and fix that while I'm looking at it. And that has player name is equal to true. Well, yeah, kind of. We'll run with that until we run into a problem. And then for get player name, we're just not going to do anything. We don't need to, because we're inside of our console game request. That's being taken care of for us. It's still something we want inside of our expression, but it doesn't really matter for here. Okay. And then if we don't have a target, we're returning. So if we actually get inside of this method, we know we have a target. So before we were saying get target and we're passing in the room and the arguments. Oh, that's going to be tough because I don't know if we really want a room this early on. This is going to be a great chance to take another look at our chain of responsibility and our dependencies. So this is actually really nice. Okay. So let's leave that kind of broken for now. Go back into our game request. This all looks fine. But we do want to do the target name. The target name is equal to args.1. Cool. So kind of threw a lot of that in there at once, but I think it looks pretty clean. And we've got these two methods we aren't using, get player, get room. And the reason we aren't using that is because we've got this, instead of our chain of responsibility, we've got a dependency handler. And that's where we want to get these things. We don't want to get them anywhere else. Let's go ahead and crush these out of here. Let's go ahead and remove the things we aren't using. And I just cut those two methods out because we're going to want to use them someplace else. Okay. So I'm going to delete this for the 10th time. Okay. So I'm also not going to need any of these things. Presumably. We'll leave them in there just for a second, so I don't have to control Z myself into embarrassment again. Okay, let's quickly go over to our handlers. So I got get player. I feel like I copied these in here. Yep. So they were already in there. Just a bit of duplicate code out there. So it's always good to have better code coverage. Jim Dude says grabbed ice cream. Well, now I'm jealous. Congratulations. I would like some ice cream. It's like 90 degrees where I am. It's ridiculous. Okay, so going back over to our console strategy, which had all this heavy stuff in there. Still chewing away at it. But let's go back in our dependency manager. I'm sorry, handler. So this is where I want to get rooms and get targets, right? Now, I do think that we want to add the game request to the action context, because that fits in line with what a context should do. It should actually encapsulate all these things so we don't have to go looking for them. Cool. And then inside of our hive mind, we're going to say game request is equal to the request that comes in, moving kind of quickly. We no longer need to do this. We're going to handle that inside of our dependency. And we no longer need to get this current action. So we're cleaning up things left and right, people. It's an action context. No longer need current action. And then instead of our dependency handler, now that we have our request, we're going to say, because we're loading dependencies, if action context dot game request dot let's go ahead and make that public, because we need that. Public bool. Public bool. Da, da. Wow, I just broke into song almost. You gotta watch me. If I get too comfortable, you're gonna see a lot of private time come out. That is not good. Not good for anybody. Alright, jumping around a bit. Making a few quick fixes. Got about 15 minutes left in the stream, and I think we're gonna make some good progress. So just set ourselves up nicely for day number 2. And if you've been following along, we aren't doing anything new or too complicated, and it should be really rewarding at this point, I think. So, go back into the dependency handler, and now that I've got access to, if I has target, then I want to, remember over here we were doing, this. I am just control-Zing that a lot. Alright, so if I have a target, then I want to do action context dot target is equal to get target, and then I've got my room, do action context dot room, and then action context dot game request dot target name. Cool. So now it's now the job of our game request to evaluate the incoming command, the context, turn it into this expression, right, and then pass it on to our hive mind. Then our hive mind is going to kick off our chain of responsibility. And the first thing that our chain of responsibility does is take a look at our game request, that expression that's been interpreted, and then it's going to resolve all the dependencies that it needs before it passes it on to our auth handler. So we're coding like big boys and girls now. Jim did ask, do you have a standing desk or just a high-up chair? I have a standing desk, and it's turning more and more into kind of like a recording studio, which I'm kind of excited about. But trying to save my body, save my knees, save my back. Trying to buy into the latest fad that sitting is death. We'll see. I met my step goal for the day though, so that's exciting. Okay, so that all looks good. And again, remember the whole point of this was to clean up all of the noise we had in here before. We don't break anything either. So the game request now needs our player name. And here we're doing a little more interpretation that we want to do someplace else. So I like that. So instead of our game request, if the player name is equal to null, then what do we know? We know that the game action is going to be a login. That's what we know. What else do we know? Let's delete that. Okay. Then we know that we want the name of a new player to be the command. Alright, so we can change that a little bit. Just a little bit. Because, we'll cheat here a little bit, because what we're going to be doing down here is you can get rid of this target, get rid of this game action, get rid of these two, and bring this a little more confidently. Because then we're going to do game request dot interpret and the command. And then when we get into the interpreter, so I already said if the player name coming in is null, then the game action equals login. That is good to know. So that's good information to use in our get player name. Because remember, in the abstract expression, we're going to get the game action. Let's do this. If game action does not equal login already, we're probably going to fine tune this at some point. But right now we just want to get all of the players on the get all of the things on the table so that we can deep dive tomorrow into what we've done and clean up a bit. Probably. Alright, so when we go to interpret, we're going to say, okay, give me the context. And evaluate the context. And if upon evaluation our game action is equal to none, just return. If upon evaluation we already know that our game action is equal to login, then let's go ahead and, or does not equal login, then don't get the game action, because we already know that. Let's come back over here to our evaluate. Okay, so this is actually a good place for our if player name is equal to null, right? Do we even need, I guess we do. Because we want to say else. Cool. So we're going to instantiate this with the player name. If it's null, then we're going to set the game action to login. Otherwise, we're going to set the player name and set has player as true. I think that makes sense. And then, if it's login, whatever command coming in, we assume is going to be the player name. So, in get player name, if game action is equal to login, player name is equal to args.0. Man, this is a lot of we better be right kind of code going on. So we're getting kind of dense here. We're getting kind of smarty pants. Cool. So now we've successfully replaced this logic as well. And this logic. So in theory, all of that goes away. And instead, and we'll get rid of this response as well, because the hive mind is going to return a response. It's great for troubleshooting, but we might just add it back if we need it. And we'll make this an implicit declaration. All right. We're going to build here to find some bugs, but and again, we kind of just chopped right through it. So if you've got like I don't even know. If you have any questions about what just happened, I do apologize. Okay. So let me take this. I'm going to do a game request, .game action. So we're going to need to replace that everywhere we see it. And we use it a lot. Mikola in chat is sleeping. I'm sorry, Mikola. Long day? Oh, this is boring. Oh. Yucks, yucks. Yeah, it's good stuff, though, as far as being able to look at a pattern and really understand, I guess, the scope and implication, not just now, but also in the future. It's so powerful to be able to say, okay, whatever I'm getting in, I have the ability to properly architect it in a way that's not going to impact my core business logic, that's extensible, and that is, I'm gonna say, sanity producing. It's clean, it's terse, it's smart, it's clever. I take back the clever part. Because I do always say to myself, don't write clever code, write smart code. Okay. It's all cleaned up. Our dependency handler is more or less cleaned up. And we're about 2 minutes away from hitting the buzzer. So let's go back into our object expression. So we had a bunch of stuff inside of our process strategy. And we replaced all of that with this idea of an expression, something that we can take input, evaluate it, and create an expression out of it. So that's really exciting. It makes things cleaner, more extensible, something that we can use in the future for different endpoints, different inputs from the user. And it should all just work. And whenever we want to create a new interpreter, we're just going to follow this same kind of approach. Put all of our guts in here. This all looks much cleaner. So we're down to 57 lines of code. And if I just hold down the Control Z button, we got rid of a lot of stuff. Hold on the Control Y button to move back in time. So, much better. And now we can actually focus on having this process strategy do what it's supposed to, which is gatekeep messages coming in from the client. It's not its responsibility to interpret those things. If we want to call it a mediator, we can. Its job is to take in this thing, know what it is, right? Know that it's a console request. Know that it's got to call the game request interpreter, which I guess we could call console game request, but we'll leave naming for another time. Okay, so I'm sure this is going to break, but let's just see what happens, and then we'll fix everything tomorrow, because it looks good, but looking good and running aren't the same thing. So, our connections happen, which makes sense. Again, business logic is gold, because if we didn't touch it, it should still work. Right? If it's decoupled properly, you should have that confidence that, hey, this part of it should still work. So I'm going to type in Gary. I get here. I'm going to step in to my new game request. Player name is null. So I'm going to set the game action as login. Come back out. Then I'm going to interpret. So my context is just Gary. I'm then going to evaluate that context. So I'm going to split it. It's not greater than 2. It's not equal to 2. So we know that it's an action, but it has no target. So that's what we've gained from evaluating this. Come back out. The game action is login. So it goes past both of those guys. And then we go to get player name. Let's go into that. Then we say if the game action is equal to login, set the player name to args0, which is going to be Gary. If it has a target, then return. Oh, I'm sorry. Wait a minute. No. Yeah, we want to return if it doesn't have a target. Let's go ahead and stop it there. If it does not have a target, then return. Let's try it one more time. Interpret, 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 interpret. Yes. So, taking a look at our game request. Oh, hang on. Where's my base? That's weird. It does not care to show me anything. Let's hop in here. Action context is equal to new game request. There we go. Alright, so in our game request, we see that the context is Gary, the action was login, does not have a player or a target. Ooh, it does have a player. So let's look at where we set that. I'm just clicking around randomly at this point. Did I close that? Probably did. Yeah, we really want it right here. Okay, so has player is equal to true. back through, coming in. Look at our game request. Alright, looks good. Let's go into our dependency handler. We caught our first exception. Yeah. Alright, so we got pretty far. We're going to go back in tomorrow and we're going to fix all of our bugs, get everything wrapped back up, and then we're going to, in 2 really short sessions, have implemented the interpreter pattern and really cleaned up our code. So, admittedly not the most exciting session, but if you were scared of the interpreter pattern before, seeing how easily it came in and how much good it did to the cleanliness of our code and the structure of our code should be motivation to tackle it yourself and really get some good use out of it. Okay. I'm going to start closing up, and as usual, thanks for checking me out, and look at the channel for relevant links to the GitHub and such. And once I'm done checking in, I will wave everyone goodbye. Alright, cool. Everything's checked in. Pull the code if you like, see what's going on, or hit me with questions. And I will see you guys tomorrow. Take it easy.